Absorption Law says that x plus x into y is equal to x. Wherever I have multiplication, I'm replacing it with a plus. Hello everyone, I welcome all of you to the session 3 of Boolean logics. It's very important that all of you should go back and check what we have done in the session 2. My dear students, we have discussed different laws in the session 2. The continuation of that laws is what I'm going to discuss in this session also. So before I start this session for all of you, let me just give you a small recap. So what is that we have done in the previous session? So we have discussed three things. Remember this, I started with p square. So what is that you're saying this? Please remember this code, okay? So p square, I square, c square. This is what I have done in the previous session. Only three letters I have discussed. What is this? P square in the sense properties of 0 and properties of 1. So please remember this. This is very easy for you to remember. Properties of zeros and properties of 1. That's what you have to remember. That's what you have to call it as p square. It's very easy to remember. What is this I square? You have two laws, right? So you have independence law and you have involution law. Right? You have two laws, independence law and you have involution law. That's what I will call it as I square. One more you have, that is c square. What is the c square? You have commutative law and you have complementary law. So you have two laws again here. Is it easy for you to remember? Yes. Make sure that by the end of this chapter, all the laws should be in your fingertips. Then only you will be able to write the equations and simplify the equations. So fine. So go back and check what exactly we have discussed with respect to these laws. What is that I have for the day then? I have three different more laws, guys. One is associative, distributive and absorption law. So this is what you have in this session. Along with that, I will also present a revision chart so that it will be very easy for all of you to recollect all the different laws what we have. So without wasting much of your time, we are starting the session. Alright, so the first law that we have is associative law. All of you know that associative law in the sense it will be x plus y plus z. Okay, so you have to write like this, x plus y plus z. Okay, you will have the brackets for y plus z. So fine. So this is your LHS and what is this for RHS? So please observe, you will have the bracket for x plus y. You will have the brackets for x plus y. Here you have the bracket for y plus z and you will write the bracket for x plus y. That's a major difference that you have here. And then after that you have plus z. So this is the simple equation that you will be having for associative law. It's very simple. You just have to write like this. All right, x plus y plus z is equal to x plus y plus z. All right, so you will write the brackets for this first and then you will write the brackets for this. That's it. Okay, it's pretty simple to remember this. So fine, we know this. Please go ahead. How to write this? How to write the graphical symbol for this equation? That's very important. So fine, what is that we need to understand? So why the brackets are very important here? How exactly it is playing a vital role? So please understand here very carefully. So guys, what is the equation that I have? I have x plus, okay? Treat this x plus y plus z, all right? So treat this as one input, this as another input, all right? So treat this as one input and this as another input. So that is what you have to keep it in your mind right now. All right, so let me erase everything completely for all of you. So hope you remember. So you are keeping this as one input and this as one input right now. So what is that you will write? So what is the gate you have here? So you have OR gate. So imagine I will write the OR gate for all of you. All right, so I have two inputs. So what is the first input for this OR gate? So x, you will write x. Do I have y plus z? No, I don't have. So for that I need to write. So how do I write? So y plus z, I need to write. The input here should be y plus z. So how do I write now? So again I have to write y plus z. So please observe here. Y plus z, two inputs. Y is this and z is this. Alright, I take two inputs. So what is the gate that I have to use here? Plus in the sense R. I will write this. Alright, the output of this will be the input for this. Am I being clear? What is the gate that I'm using? I'm using R. So what is the gate I'm using? I'm using R. What is the output of this? So this statement, whatever I have here, I will write. Okay, this is the output. Got it here? So this is this looking the same? Yes, this is how I write the diagram. So instead of writing this, what they have done is they have written R. That's it. They have written R. So fine. So for this equation, you have written the graphical diagram here. Okay. So for this, I have to write now. Same thing. How many inputs you have here? This is 1 and this is 1. So you are simplifying it for yourself. All right. So for first, okay, you have to write the graphical symbol. So x plus y. So what is the gate you have here? You have OR gate. So fine. You will write OR gate. You will write first and two inputs. What is that? You have x and you have y. So you have the output. So x plus y is your output. So fine. Alright. So this is one input and this is one input right now. So let me write two inputs now. Again, I will write two inputs. Which is the gate here? In between, you have OR gate. So let me write the OR gate for you guys. Alright. So I have written the OR gate. So one input is z. Another input is x plus y. The output of this is x plus y, right? So I will just connect to it. Yes, that's it. All right. What is the gate here? OR gate. What is the gate here? OR gate. So this I will write it as R. Is it looking like a same? So this is how you will write the graphical symbol. Please understand this. This is very, very important. All right. So hope you understood the graphical symbol, how to write if I get the equation. So let me tell you a simple thing. Okay. So how do we write the graphical symbol? Let's understand. Let me just give you some tricks. Say for example, I have AB plus ABC. How do I write the graphical symbol for this expression? How do I write? That's a question now. It's very simple. So how many inputs I have? How many inputs I have in the question? I have two. What is that? A and B. So what is the operator that I have in between? So if I don't have anything, so it means to say that it is dot. Dot in the sense what? Multiplication. Multiplication in the sense what? And. So that's what you need to think. So fine. First, let me write for this. Okay. So how do I write? I have to write two inputs. So fine. A, B. I have written. What is the operation that I have to write? I have to write the multiplication. Multiplication in the sense which gate? AND gate. So fine. I will write the AND gate. Alright. So I am done with this. So this part is done. Okay. So here for this equation, this is one input. Alright. So this is the second input. Yes or no? Yes. But I have three variables here. So I have to consider. After A, what is that I have? Nothing. Then dot. After B, what is that I have? Nothing. Then dot. So what gate I have to write for this? Let me write the logical diagram for this first. How many inputs I have? 3. So fine. I will write 3. What is the gate that I have to use? Multiplication. Then which gate? AND gate. Alright. A, B, C. You got the answer? Yes. So guys, now I have this, okay, and I have this. So what is the gate that I have used in between? I have to use plus. Plus in the sense what? Which gate? OR gate. So this is one input, alright. So this is one input. I'll use OR gate. So this is how you will write the diagram for the given equations. This is how we write the diagram for the given equations. So this is very simple. All right. So moving on to the next one. Now all of you will be able to write the graphical symbols for the given equations, right? Yes. So now guys, we have the truth table for the associative law. All right. So this is the law that I'm going to prove with the help of truth table now. So how many variables we have in the statement in the law? So we have X, we have Y and Z. So three variables we have. So when we have three variables, how many combinations I should take? So we have already discussed this in the truth table. Come on, tell me. So 2 to the power of 3. So since we have X, Y, Z, three different variables, we have to take 2 to the power of 3. So 2 to the power of 3 in the sense 8. So that's why I have 8 different rows. 8 different rows. That's what you need to remember. So fine, how do I write? So first you will write 4 zeros and 4 1. That should be the first column. Then after that, half of it. Okay, here I have 4 zeros. Now I'll start with 2 0 2 1. 2 0 2 1. Done. Then after again half of it for the third one. 1 0 1 0 1 0 1 0 1 0 1. Like this, I will finish off all my input. First, I will write all the inputs. This table, I will fill it without any calculation. That all of you should know. So we have done it already. So fine, this we understood, sir. Then, how do we calculate this? This is very simple, which we have already discussed again, right? So what is that we have discussed? Y plus Z. What is the operation that we are doing? Addition operation. So y plus z. So please understand, 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. Obviously, 1 plus 1 will be 1. 0 plus 0 is 0. 0 plus 1 is 1. Again, 1 plus 0 is 1. 1 plus 1 is 1. So you got to know how we got this. Binary addition. So fine. What is the next expression that we have? X plus y. Let's perform that. X plus y. 0 plus 0 is 0. 0 plus 0 is, this one, 0, and 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 0 is 1. Again, 1 plus 0 is 1. Again, 1 plus 1 and 1 plus 1 is 1, 1 again. So you got to know this also. I don't have to explain this, but still, so please remember how are we doing it. Alright, so fine. After that, so what else I have to calculate? So I have to calculate x plus y plus z. Do I have x value? Do I have x value? Yes, I have x value here. So do I have y plus z? Yes, I have y plus z here. Now I need to perform the addition for this two. I need to perform the addition for this two. This is 1 and this is 2 now. Addition should be performed between 1 and 2. That's what you need to remember now. Alright. So the resultant, I will be writing it here. Alright. So I have 0 plus 0. So it should be 0. Correct? So then I have 0 plus 1. Okay. 0 plus 1. It should be 1. Alright. I have 0 plus 1. 0 plus 1. It should be 1. So that's what you need to remember. Alright. So then I have 0 plus 1 again. Okay. 0 plus, sorry, not this one, this one. 0 plus 1 is 1 again. So keep checking. So again I have 4 ones. I don't have to check there. Okay, I don't have to check there. Since I have 4 ones here, immediately I'll write 1 1 1 1 1. Because obviously, even if I have zeros there, obviously I will end up with a 1 as my result, right? So that's how I will be writing. The same way you will calculate for this also. Alright, so please observe, am I getting the same value here? Am I getting the same value? X plus y plus z is equal to x plus y plus z. So that's what you need to remember. Is it equal? Yes. Hence, it is proved. So whatever the values that I have here, so the same value I have there. So, sir, we understood this table. We understood this table. Then how did you write this? So let's understand this. Okay, let me just tell you that. So obviously, I have 3 different variables. First, what is that I'm going to do? I will write x, y, z. So fine, I have written that. What else I have here? Do I know the value for y plus z? No. So first, I will write that y plus z. Alright, so fine. Then after that, do I know the value for x plus y? No, I don't know. So for that, I need to calculate. So I will write x plus y. So fine, I got it. Then I have to calculate for this. I have to calculate the value for this, right? So I will write this. So that's what I have written there. X plus y plus z. The same way, I have to calculate the value for this. So that's what I have written there. So that's how we write the truth table. Alright. So hope you understood. I have spent a little more time on this so that I want all of you to understand that. All right. My head rotates when I see these zeros and ones. All right. So guys, jokes apart, moving on to the next topic. So the next law that I have in the associative law. So I was discussing that law with respect to the OR gate. The same way I have a AND gate here. So please observe. So I have x, y, z is equal to x, y, z. Same thing, what we did there. Same thing. First I'll write the brackets for this and then I'll write the brackets for this. Very simple. I was writing remember the first law what we discussed with respect to OR gate. So what we did? So we did like this, right? X plus y plus z. We are using the OR operation. So what we did? So we had the brackets for this. Same way x plus y plus z. So we had the brackets for this. So but here I'm using the OR gate. So you will have the brackets for this and this. Same thing. Okay. So now let's understand how to write the graphical symbol for the given expression. All right. I have x and y, z. Let's understand and let's write this. So guys, please be careful and listen to me carefully how to write this so that if you have not understood the previous diagram. What is that I have? X into yz. How many inputs I have? So I have 2 here. All right. So let's write that. So I have 2 x and yz. So what is the gate here? Dot in the sense and. All right. So I'll write AND gate. Fine. Dot in the sense I have to write AND gate. So do I know? Can I write like this? No, I have to write the output of yz. So for that, how do I write? So first I have to write the gate for this. How many inputs I have? 2. So let me write y and z. So what is the gate I have? AND. So I will write the AND gate here. So that is the output, okay, which I will connect it here. This. So do I have the same diagram? Yes. At the end, I will write OR. The same way they have written that. So for this, I want all of you to write the truth table. So try and write the truth table for this, which I have shown with this. The same way you have to write the truth table for this. You just have to use AND operation. That's it. All right. So fine. Moving on to the next one. The next one that we have is distributive law. It's simple, and if you have understood the previous law, it's quite simple. You just have to remember only this statement. All right. So if you remember the statement, the rest everything will be same. All right. Please understand what I have. So guys, I have, when it comes to distributive law, all right, I have x of y plus z. X of y plus z. When I have this, all right, so what will be my result? So please understand x into y. I'll have x into y plus x into z. All right, this will be my answer. All of you know this. So we know this. So please go ahead. All right. So this will be the distributive law. This will be the distributive law. So fine. How do I write? How do I write the graphical symbol for this? Let's understand this. Quite interesting. So what is that I have here? How many? Let's imagine how many inputs we have. Imagine this is 1. Let me change the color so that you will be able to understand it clearly. So this is 1. All right. So this is 2. Let's imagine like this. So fine. What is the gate that I have to use? Dot in the sense AND. So fine. I will be writing the AND gate now. So listen to me. I have 2 inputs. So one is x. Let me just write x. So fine. I have written that. The next one is 2. Okay. For this 2, I have y plus z. Y plus z I have to take. The input of y plus z I have to take. All right. I will just leave it empty now. Y plus z, how do I write? So I have to take 2 inputs. One is y, another one is z. So fine. So plus in the sense, what gate I have to use? OR gate I have to use. I have to use OR gate. So fine. So this is y plus z. Okay. This is y plus z. All right. So what is the gate I have here? So I got the x and I got the y plus z also. What is the gate I have to use? AND gate I have to use. I will write AND gate. All right. So I have AND gate with me. So is this looking like this? Yes. Right. This is how I write the graphical symbol for this expression. For this one, I've written. I have to write for this. So I think all of you will be able to write for this. So quickly, if you're watching my session, I want all of you to finish it before I finish it. All right. So how many inputs I have? So I have 2. All right. So this is 1, and this is 2. All right. So I have x and y. So what is the operation that I have? Multiplication. Multiplication in the sense and. So fine, x, y you have written so. Alright. So I have one more, x and z. So fine. What is the gate? What is the gate here? And gate again. Alright. Let me just write and gate. So since I have x here, let me just borrow it here. Alright. So even if you can take it from here, but since I have the x already, I will just connect it. Alright. I have z. Alright. I have z. So I will write like this. So what is the operation that I have here? OR. So these two will get connected to OR. These two will get connected to OR. Is it looking like this? Yes. This is how you will be writing the graphical diagram for the given expression. So fine. So you understood this. Moving on to the truth table for the distributive law. So guys, I think it's very, very simple, which we have already discussed the same thing. All right. What we have discussed with the previous law, same thing, but we will be just writing the truth table and then we'll be performing and then we are trying to prove. All right. So fine, you all know that how many variables we have. We have 3 variables. So when we have 3 variables, 8 combinations, 2 to the power of 3. So fine, we know how to write this 3, right? So then first, do I have y plus z? No, I have to calculate. So I will write y plus z. The same way, x into y I will calculate x into z. So fine. So I have to take this one, all right, this one, the second one, and third one. So fine, I will take this. Then after that, the final resultant, what is that I will take? So after taking this 3, all right, 1, all right, 2 and 3. After taking this, so this is 1, okay, I need to calculate. This one is what I need to calculate, 4, and this is 5, all right. So that's what I have here. So look here, I have y plus z. So y plus z is the first one, all right. The next one is x into y. So please observe, x into y I have. So what is the next one I have? I have x into z. So what is that I have? X into z. So I have that. So right, what is the next one that I will have? So please observe, x into y plus z. So please observe here, I'm taking the fourth one, x into y plus z. So fine, the fifth one should be x into y plus x into z. That should be there. All right, do I have that? Yes, I have that. So this is how I write the columns first for the truth table. All right, once I'm done with that, so you all know that how do I write these 3 columns. When I am done with this, how do I write the values? You all know, right? So I don't have to explain that, but let me just show you all, like, how do we do it. All right, y plus z, okay, y plus z. So plus in the sense addition, binary addition you have to do. Y plus z, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1, 0 plus 0 is 1, is it? No, 0, okay. So 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. So you got to know how did I got it, all right. The same way I have x into y, I have to perform multiplication now. So x into y, all right. So fine, 0 into 0, it should be 0. 0 into 0, it should be 0. 0 into anything is 0. Again, 0 into anything is 0. Again, 1 into 0 is 0. 1 into 0 is 0. 1 into 1 should be 1. All right, I have 1. 1 into 1 should be 1. Okay, so hope you got to know how did I calculate. The same way I have x into z. I have to perform x into z. This one into this one. All right, so keep checking the answer for this, guys. 0 into anything is 0, 0 into anything is 0. First 4 columns is 0. All right, so I have first 4 columns 0 by closing my eyes. All right, the next one I have, all right, the next one I have 1 into 0, it should be 0. All right, 1 into 1, it should be 1 again. So 1 into 0, it should be 0. 1 into 1 is 1. So that's what I have here. All right, then after that, I will be performing this operation. What is that I'm performing? X into y plus z. X into y plus z. So this is what I'm going to perform there. 0 into 0, it should be 0. All right. X into, so please observe, x into y plus z. So that's what I'm performing there for the last row, right? So 0 into 0, it should be 0. Again, 4 zeros. By closing my eyes, I will write, because my x value is 0. If you multiply anything with respect to 0, so you will end up with 0. All right. The next one I have is 1 into 0. Obviously, it is 0. The rest 3, I have 1. And here also I have 1. So I will write 1. So 3 ones I have. So this is how I'll calculate. Again, what is the last one I have? X, Y plus XZ. Alright, I have what operation here? I have plus operation. So please observe this. So first 3 zeros I have, I will leave it 0. The next 2 zeros I have, I will leave it 0. The next one, 0 plus 1 is 1, 1 plus 0 is 0, 1 plus 1 is 1. So both the columns are matching with the values. Yes, of course it is matching. So it is proved. Alright, so this is what you need to understand. Alright, moving on to the next law of distributive law. So guys, please observe here. What is that I have? So I have x plus yz is equal to x plus y, x plus z. So please tell me, how do you get this? So it's very simple. All of you know this. I don't have to speak about it. All right. So guys, the same thing. You are just converting. Okay. You are just converting the same distributive law. So when I have this, all right. When I have this, how do I write this graphical symbol? All of you know how to write the distributive law, right? So when I have this, how do I write this? All of you know that. We have already seen this, how to write this. Let's check that. I have x plus yz, right? So how many inputs I have? So in general, I have 2. Let's consider this one and this one. All right. So let me just write x. All right. So I have plus. So plus in the sense which gate I have to use? I have to write the OR gate. So fine. So you are writing the OR gate. So let me not maintain the neatness. All right. I have yz. So what is that symbol here? AND gate. So fine. I will write the AND gate. So for this, y and z, output of this will be connected to this. So what you need to remember, please observe here. That's what I have here. The same way to write the graphical symbol for that also. All right. So this is how I will be writing the graphical symbol for the distributive law. So here, how do I write? It's very simple. What is that I have here? This is consider this one as one input and this is the second one. All right. So how do I write here? So I have x plus y. So let me just write OR gate. This is x and this is y. So what is the next one? I have x plus z. So let me take the x from here. So again OR gate. Okay. So this is z. So what is that I have here? Which gate I have in between? If you don't have anything, it should be AND. So fine, I will use the AND gate. All right. So that's what I have here. This is how you will be writing the graphical diagrams step by step. All right. The same way I have the last law. What exactly the last law that I have? Absorption law. When I have the absorption law, so for this, guys, you have to write the truth table and practice, like which I have shown with the last one, right? So same way you have to write the truth table for this, right? The next one that I have is absorption law. What is that I have when I have the absorption law? Absorption law says that x plus x into y is equal to x. X plus x into y is equal to x. That's what you need to understand. How do I do this? How do I write the graphical symbol? I think by now all of you would have understood. So first you will write the x. So what is the gate you will write? You will write the OR gate here. So fine. You have to write the AND gate for x and y, right? So that's what I'm doing here. So I'm taking the x here and I'm taking the y. So which gate I have to use here? Between this, I have to write the AND gate. So the x, I'm taking it as one input for OR gate, and again the output of this gate I will be taking it as a input for this OR gate. Finally, I will have the x as the output. So how do I prove this? How many variables I have here? I have x and y, two different variables. When I have two different variables, how many combinations I should take? So 2 to the power of 2. 2 to the power of 2. So 2 to the power of 2 is 4. Alright, 0, 0, 1, 1, 0, 1, 0, 1. So fine, I got it. So how do I write the truth table? So do I have x value? Yes, I have x value. Do I have x into y? No, I don't have. So fine, I have to write x into y. So fine. After that, what is that I have to check? So I have to check for this x plus x into y. So that's what I have done. X plus x into y. So this x plus x into y should be equal to x value. So that's what the truth table that I should have. So fine. So you all know that these two columns how to write. The next one x into y. So you all know that how to calculate AND. Alright, 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. So fine. Now x plus x into y. So now x plus x into y, I have to perform the addition for this 2 column. Alright, 0 plus 0 is 0, 0 plus 0 is 0, 1 plus 0 is 1. Alright, so I have 1 plus 1 is 1. Okay, so now do I have the same values whatever I have in the x in this x plus x into y? Yes, same. So then this is proved. Hence this is proved. The absorption law is proved with this truth table. This is what you have to remember. So guys, again I have the next law in the absorption law. Please observe, what is that I have? X into x plus y. What is that I have? X into x plus y is equal to x. What is that I have here? Please observe. X plus x into y is equal to x. This is what I had. So what is that I have? The next one. So x into x plus y. Alright. X into x plus y. So please observe here. So instead of plus here, so I had multiplication here. I'm just interchanging. So what is that I have? Let me just write and show you. So please observe. What is that I have? X plus xy. What is that I have? X plus xy. So this is what I had. Okay, x plus xy. So what is that I have here? X into, alright, x into x plus y is equal to x. So wherever I have plus, I am replacing it with a dot, that is multiplication. Wherever I have multiplication, I am replacing it with a plus. So here I had plus, I am replacing it with the multiplication. Here I have multiplication, I am replacing it with a plus. That's the second law that I have. So same way I will be writing the graphical diagram. So fine, let's try and understand how to write this one. So I have to write for this. So I have x. So fine, I will write x. Dot in the sense which gate? AND gate. So fine. So what is this? Another input x plus y. Plus in the sense OR gate. I have to use the OR gate. So two inputs. One is x. Let me just take it from here. Another one is y. So the output of this I will connect it to this. This is equal to x. That's what you need to understand here. That's what we have written. So for this also you should write the truth table. That's what you need to understand with respect to absorption law. So now I have given you the table. So guys, I will just move out of the frame. I want all of you to take the screenshot of this table. So in this table, I have given you all the laws what we have discussed till now, so that it will be very easy for you to have a quick look and you will be able to remember this easily. Alright, I want all of you to have this laws in your fingertips. This is very, very important. Alright, so what is that we have? We have discussed properties of 0. Alright, we have properties of 1, idempotence law, involution law, complementarity law, and then commutative law, associative law we have discussed today, and distributive law and absorption law. This is what we have discussed. So guys, so please go through with all this law which we have discussed. It's very important. So without this, we cannot solve a lot of equations. Using this, we will be solving a lot of equations in the coming classes. So I want all of you to have this in your mind whenever I say, no, like if I have come across 1 plus x, so what should be 1 plus x is equal to what? If I say, you should be able to tell me it is 1. All right. So like that, you should know all this laws. By saying this, I have come to an end of this session. Thank you everybody for watching, and if you have learned something, so don't forget to please click on the like button and share this video with your friends. Take care. Bye bye.